Hey class, in today's lesson we're going to talk about vectors in the plane, which is section 6.3, part 4. Our objectives are to find the direction angles of vectors and to use vectors to model and solve real-life problems. So direction angles. So it says if vector u is a unit vector such that, I'm pretty sure that I was supposed to say theta, is the angle from the positive x-axis to vector u. The terminal point of vector u lies on the unit circle, and you have vector u equal to the component form of xy, which is essentially the component form of cosine theta sine theta, which is equal to cosine theta I plus sine theta j. The angle theta is the direction angle of the vector u. So again, as I mentioned, so that I don't forget, there is a theta right here. Oops. Yep, right there. All right, let's keep going. So it then goes on to say so this is just an example. So vector u, again, is coming from the origin, and its terminal point lies somewhere on the unit circle, and we know it would be on the unit circle because the unit circle has a radius of 1. And so the x component of it would be cosine theta, and the y component would be sine theta. Okay, so direction angles. So it says, suppose that vector u is a unit vector with direction angle theta. If vector v is any vector that makes an angle theta with the positive x-axis, then it has the same direction as vector u, and you can write that vector v is equal to the magnitude times cosine theta sine theta, which is equal to the magnitude times cosine theta I plus the magnitude times sine theta j. You can also use tangent theta equals b over a. So in example 7, we're going to apply the basic portions of direction angles. So it says find the direction angle of the of the vector u equal to 3i plus 3j. So this one is an okay problem. I don't really care for it because it's using the same number, but the main thing that you need to understand is that if I wanted to find the direction angle, I could simply use tangent theta, because remember, this 3i is kind of like in the cosine position and 3j is in the sine position. So this would be b over a, which would be 3 over 3, which is 1. And then to find, well, what is the angle when the ratio is 1? Remember, we use the inverse property. So the inverse, or tan's inverse of 1 would be 45 degrees. Okay, so tangent has an inverse of the ratio 1 at 45 degrees. And we're going to leave this just with quadrant 1 for now. Okay, and try 7 says find the direction angle of the vector 3i minus 4j. So again, same deal. We use these basic ones for tangent in this form. So we will have, again, b over a would be negative 4 over 3. And so then to find the angle whose ratio is 4/3, we use the inverse property on our calculators, and that would give you negative 53.13 degrees. And in our calculators, we don't want anything that's negative, so to make that positive, we're going to add 360 to it, and that's going to give you 306.87 degrees. That's a degrees. All right, so let's actually apply this to a problem. So it says find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle of 30 degrees below the horizontal. So according to our formula, vector v is equal to the magnitude times vector v times cosine theta. Oh my goodness, this is terrible. Cosine theta I plus vector v sine theta j. Okay, so the magnitude is actually given to us. Remember, magnitude is length and direction, and so velocity actually represents the magnitude for our problem. And they told us that the speed is 100 miles per hour. So we're going to use 100 as our magnitude in both spots. Okay, and then let's think about it. It says that the plane is traveling at 30 degrees below the horizontal. So if we would typically start at the positive x-axis, to be honest, this isn't fair. It's only that I know this, but because it's 30 degrees below the horizontal and it's descending, I know that it's actually going to be in this direction rather than this other direction. They could have been a bit more specific to let you know that, but again, this portion here is 30 degrees below the horizontal. So the whole portion, remember, is actually 210. And that's the theta that we're going to use. So we're going to say cosine of 210 I, if my pen will work, plus sine of 210 J. Okay, and then if you remember, cosine of 210, well, cosine of a 30-degree angle, and in that quadrant will give us negative square root of 3 over 2. And then we have I plus 100 times sine of 210 in that quadrant is negative 1/2. And then that's J. So if we multiply the tops and then divide, we would get negative 50 square root of 3 I. And I got that because I did 1 times negative square root of 3, which is negative 100 square root of 3. Divide that by 2 and I get negative 50 square root of 3. Minus, because that 100 times negative 1 will give us negative 100, and then divide that by 2, and that's negative 50. So minus 50J. And then to finally put that in component form, we will get as an answer negative 50 square root of 3, comma, negative 50. Okay, and that is our final answer. Guys, if you have any questions, please be sure to come see me.